Okay, hi. Now let's continue with the second subtopic, which is differentiation of logarithmic function. So to find the derivative for functions involving log, what you have to do is you need to remember these properties. There are four properties that you need to know, and let's move on with them right now. For the first one, you have if you differentiate ln of x with respect to x, then what we are going to get is 1 over x. This is what I've shown in the previous video. And for any functions involving log, we are going to use the same method, the same concept. So for the second properties, you are told that if you differentiate ln u with respect to x, then by using chain rule, what we are going to get is 1 over u multiplied by du by dx, where we know u is equal to f of x. So please take note at this condition. This is also the same if you use almost like power rule. What happened here is if you have the differentiation of ln of f of x with respect to x, and then what we are going to get here is we just take 1 over f of x, and then differentiating fx will give us f prime of x, and we can just rewrite that f prime of x divided by f of x in a simpler form. Okay, those are actually the same, but we use different method. But no worries, both are actually the correct answer. Okay, so for the third properties, what you have here is if you differentiate log x base a with respect to x, then what you are going to get is 1 over x multiplied by ln a. So how do we get this one actually? Now let me explain. What you have to do is, if you are given y is equal to log x base a, then to find the derivative, we cannot differentiate immediately and get the answer unless you remember these properties. But if you can't remember that one, then what we are going to do is we are going to change our base. So let's change base into base e. So we are going to use base e because we know if we use base e, then that becomes natural log. So your y will now become y is equal to ln x divided by ln a. Okay, for anyone who can't follow, you can try using the formula for changing base, and this is what you will get. And now, if you take note here, ln a in our denominator is just a constant. This is a constant because ln of a number is always a constant. So if you want to differentiate this, then what will happen now is you will get dy by dx is actually 1 over ln a multiplied by the derivative of ln x. And we have seen in the first properties just now, differentiating ln x with respect to x will give you 1 over x. So I just copy 1 over ln a because that is still a constant, multiplied by 1 over x, and we can just simplify that as 1 over x multiplied by ln a, and that is what the properties told you just now. Okay, now let's go on to the fourth properties. So the fourth properties say that if you differentiate log of u with base a with respect to x, then what you are going to get is 1 over u multiplied by ln a, and then all of that will be multiplied by du by dx. And again, this only stands when you have u is equal to f of x. So this condition is quite important. So now, what actually happened here again is the same as the third properties. We are going to change base first. So by changing our base, I will choose base e. And now my question will change from y is equal to log u base a, where u is still f of x. And then my y will become ln u over ln a. And then if you want to differentiate this, what you are going to get is 1 over ln a, which is a constant, will stay there. So dy dx is equal to 1 over ln A multiplied by the derivative of ln u with respect to x. And we are going back to the second properties just now, where we can just rewrite here the derivative of ln u is actually equals to 1 over u multiplied by du dx, and we can just combine these two fractions because we know when we multiply fractions we are going to multiply the numerator and the denominator, so that gives you 1 over u ln A multiplied by du by dx, and that's it. So these are 4 properties that you have to use whenever you have questions involving logarithmic function and you need to differentiate those functions.